Let's start. Edouard, if you're ready.
Okay, so I'm Edouard Guegain from Greenspector. Today I will introduce the white papers that we released, which explain everything that we do regarding how we measure the energy consumption of software, how we estimate environmental impacts, and everything that is introduced in this white papers that we released in March of 2024. So I'm Edouard Guegain. I see in the chat a lot of people that I already know. We may have met at ICT4S or at Green Days in Toulouse or at the last hackathon. I joined Greenspector 1 year ago, and before that I was in PhD at INRIA Lille. But before we start with the methodology, I just want to give a bit of context because I often see people who know Greenspector by name, but who don't know what we work on. So I will go through a bit of a recap regarding the history of the company and what we have been working on since the beginning. So Greenspector is in fact the second iteration of an older project, an older company, which was called Qualitaire and which started in 2010. Qualitaire was working on audits, ESG audits, carbon footprint, IT for green, so very broad scope regarding a lot of projects. But quickly the company turned to static analysis for energy. So static analysis is automated analysis of source code to detect, for instance, lines of codes or functions that will consume too much energy. And to validate the optimization gained from static analysis, we had to develop a tool to measure the energy consumption before and after the optimization. And it turned out that people were more interested in the measure tool than the static analysis tool. So there was a shift in 2016 to Greenspector, which developed a tool focused on measuring the energy consumption of battery-powered devices. And the solution kept evolving over time because 2016 is a long time ago. But now the solution that we provide is a product, a software testing product, which automates black box energy measurement for mobile application. So we provide a product, which is this test tool. We also provide services, which are audits performed using this test tool. So if a company don't want to learn how to use our tool, we can provide audits with it. And we also work on R&D projects, which are more exploratory. And I don't go into the details today because the white paper is very focused on the product itself. Currently, we don't do LCA, we don't do ESG audits, we don't do power monitoring. The tool that we provide is designed for the testing step, so we don't do real-time monitoring. However, we can be involved in this kind of tasks if we can help a different service provider with a specific focus on software energy consumption. So we generally work at the service level and not at the organization level. So regarding the product itself, what I will talk about today is the test protocol, how do we measure energy consumption. I will talk about the analysis tools that we provide. I will talk about how we grade applications or software. So I'm talking here about an eco score, which is like a bit of like a Nutri-Score, but for software. And finally, I will talk about the quantification of environmental impacts based on the measures that were performed earlier. The white paper that we released is based on 3 different publications that are referenced here. So one publication regarding the test protocol, one regarding the grading, and one regarding the quantification. However, these publications are very close from the white paper, so if you decide to read the white paper, you don't need to read this publication, and if you read the publication, you don't need to read the white paper. They are almost the same. They have almost the same content. And once I'm done with all this presentation, we will have some time to talk about to take questions if you want to. So first, the test protocol. And I will also talk about the challenges of measuring energy consumption on mobile, because mobile services, so mobile website and mobile application are graphical user interfaces. And this introduces specific challenges, because if you work on energy consumption for batch tasks or for servers or for systems that are running indefinitely, generally you can use tools like RAPL or Scaffold or Power API if you want to monitor energy consumption over time. If you know when a given task starts and when it ends, it's easy to compute how much energy was used by this task, which is fairly easy to measure and to replicate. However, with the graphical user interfaces, the software offers generally a lot of different features. These features are event-driven, so the energy consumption will depend on the user. And there is also a lot of background noise. On a server, on an experimental setup, you can reduce the noise by disabling a lot of things on the OS. With mobile services, generally you have more limited control over the operating system of smartphones, and you need to keep the UI active, so you can turn off all the UI services. So all these points make it harder to measure and harder to replicate. So first we need to tackle the multi-feature and event-driven aspect of graphical user interfaces. And we will do that using the functional units that are defined for LCA in ISO 14044, which define how to measure a digital service based on given functional units. So the same app can offer different functional units. For instance, with a banking app, you would have a set of functional units. For instance, I want to look up a transaction on my banking app. I want to send money. I want to add a new recipient. And each of these functional units will be implemented by a functional path. So a set of actions by the user to reach this objective. So for instance, if your goal is to look up a transaction, the functional unit, the functional path, or the user journey will start with opening the app, logging into the app, selecting an account, scrolling to the transaction you're looking for, selecting it to highlight it or to view the details, and once you're done, you can close the application. So with functional unit, we can we can define a set of functional paths. Again, we can use different names for them. I heard user journey in the presentation earlier today. And a functional path will in fact test several features of the application. So if you want to look up for a transaction, you will use the login feature, you will use the selection of account feature, you will use the view transaction feature, and so on. And what we want to assess is not the energy consumption of the application, but the energy consumption of each functional unit of the application. I saw that someone raised his hand, so I don't know if there are questions. Gaël Duez, or otherwise I will just go on.
No, I'm not sure. I think you can go ahead.
Okay. So we defined a set of functional units. but we want to automate them in order to execute them on devices. Because we don't want to ask a user to perform all the user journeys of all of your apps at the same time. So we want to automate the functional path with a language that we developed, GDSL, in order to execute them on a list of targets, which can be Android devices, iOS devices, or IoT devices. And the language itself looks like this. So for each functional unit that you want to test, you can define a new file in GDSL, so Greenspector DSL. And GDSL allows you to control the device, for instance, by setting the screen luminosity, by enabling or disabling services. And GDSL allows you to automate the user journey using a set of instructions. So you can wait for events, you can press on a given key of the keyboard, you can wait for some text to appear, and so on. There is a lot of instructions that I didn't show here. GDSL is very thorough because we add new features every time a user needs something specific or something that they can't do right now. So there are a lot of instructions. I will just go back to the functional units. You can see that the functional path is defined as a set of actions. And in fact, we want to monitor each of these actions separately. If you have a high power usage on the functional unit, you want to know at which step of the functional unit this appeared. So in GDSL, we can also define steps, and each step is measured separately. So for instance, we'll measure a reference power usage before we start the application. And to do that, we'll create a new measure. We'll monitor the energy consumption during a given duration, and then we'll stop this measure. And we can do that for each of the steps of the user journey in order to have a per step analysis. The GDSL is essentially the same for iOS and Android. There are some instructions that are different. For instance, on iOS, you can't set the luminosity, and there are some stuff that you can't do. So you can just use the exact same GDSL path on Android on iOS, but the core of the instructions can remain the same. And when we use GDSL on IoT, generally it's not about graphical user interfaces, so we have to define new instructions specific to the IoT we want to control. So now that we have functional paths that are implemented as GDSL, they are already automated, so we need to deploy them to the physical device that we have. You can see here a picture of our test bench. There are approximately 20 devices here, including smartphones, Android and iOS, and tablets. The tablets are only on Android right now, but maybe in the future we will add iOS tablets. It's very important for us to only monitor physical devices because if you already work with power usage, virtualization is not a nice word to hear. So we only monitor on physical devices. And before any measure, we ensure that the device is stable. So we ensure that there is no background update, no services that started for no reason. We also check that they are at an optimal battery level. The energy efficiency of the device changes depending on the battery level, so we always charge them to a given value before starting a measure. And in fact, you can see that each device is connected to a connected socket, which allows us to enable or disable the charge. And before launching measure, we also do some reference measures to ensure that the energy consumption is stable. So once the device is stable, we can start monitoring the device. And what we are looking into is the battery discharge. So every time there is a measure start or a measure stop in GDSL, we'll read the battery level in order to know how much the step used in battery. We also monitor the data usage, so the network, and we try to gather as much data regarding the CPU usage, the RAM usage, and so on. However, this data will depend on the specific device that you use. I also added a per rail power usage, but it's not ready yet. We plan to deploy it in the future, but it's still in a very early stage. This kind of information will tell us if the energy consumption goes into the screen or the network or the GPS or so on. Okay, so I showed you the GDSL and I showed you the devices on which the GDSL run, but we still need to bridge the gap. So we have an additional tool. We have a command line tool which allows to start measures arbitrarily. So in this tool, we will define the name of the test that you want to perform. So if you want to test a specific version of the app, you will use this version name as the name of the test. You will also define the target that you want to deploy to. So here you can decide between Android or iOS. You can decide the level of the operating system. You can decide which model exactly you want to use. And then you can start the test by specifying which user journey to test, so which GDSL file to test, which application to monitor, and the number of iterations. Regarding the application, if you want to monitor any app, you will use the name of the app. If you want to monitor a website, you will use the name of the browser of the smartphone. And this tool allows you to start measures with only 3 instructions. So it can be integrated to CI/CD tool chains. And just launching these 3 lines will provide you with the echo score, with the analysis of the result and the estimated environmental impact. And this data can be used at a different step of development. For instance, in a DevOps process, you can use this result to locate issues from the previous version of the app. You can use this result to decide between, for instance, different libraries to use. Of course, this tool is a test tool, so it will be used in the test phase of DevOps process to validate that, for instance, optimization actually reduce power usage. And you can also decide to reject a version if the echo score, for instance, got worse. And finally, it's not exactly the goal of the tool, but you can also monitor the energy efficiency of the applications that you deployed to the store. So, for instance, if you test on a development environment, you may have different performance than with a production backend. So it's relevant to test the tool and then to monitor it once it is deployed. Arguably, I saw in our documentation that the tool is relevant for all the steps of a DevOps process, but I feel like it's a stretch, so I'll only talk about the steps that feel relevant to me. Okay, so I showed you how we measure the energy consumption on devices. Now I will talk about the analysis tools that we provide. It's not in the white paper because it's it will go very fast, so don't blink. Basically, for all the data that we monitor on the device, we provide tools to graph, to plot this data over time, and to detect if a specific event caused in one data set caused some effect in another data set. So, for instance, you can explain if the network usage is responsible for the power usage of the device. And that's essentially all I have to say about the analysis tool. So I will move to the more interesting part regarding grading. So every time you test a version of the app or a website, we will provide an echo score, which is a grade out of 100, assessing the efficiency of the app regarding 3 different indicators. So we have a time efficiency. How long did it take to perform the action? We have a power efficiency. What was the average power draw of the app during the user journey, and the network efficiency regarding the amount of data that was transmitted over network. And these metrics are calculated based on the performance of individual steps. So for a given user journey, we have a set of steps. And as we monitor the performance of each of these steps, we can show their individual performance. So for instance, here we can locate that some loading steps, CHRGT is a shorthand for chargement, which means loading in French. The loading steps are a very high power draw, which is maybe a bug, maybe an issue, but it's something to tackle. So we give a grade to each step based on thresholds. You can see that these 2 steps have the better grade, which is 5 out of 5. Then we have 2 steps at 4 out of 5, 4th step at 3 out of 5. We don't have any step at 2 out of 5, and the remainder have the grade of 1 out of 5, which is summarized here. The specific thresholds are defined empirically. So we look at all the existing data that we have, and we decide arbitrarily how much of the app we want in each of the grades. So for instance, we want 20% of steps to have this grade, 20% of steps to have this grade, and so on. And here I'm showing data regarding the energy, but the same data also exists for power and for network. So each of these steps receives a grade regarding time, energy, and network, which allows us to estimate an overall grade for each step, which is the average of these 3 steps. So this information regards the steps of the user journey, and it also allows us to estimate the performance of the overall user journey by using the average of the time of each step to compute a new grade out of 100, the average of energy, the energy consumption of each step to compute the average in energy, same for network. We use a grade out of 5 for steps and out of 100 for the path, but it's just a way to easily differentiate if we are talking about steps or about the journey itself. And the echo score is the average of the 3 intermediary scores regarding time, energy, and network, which is also the average of the scores of the steps. Our goal with the echo score is to monitor the evolution of a given software over time. So we also provide some plotting regarding the evolution for each version. Here you can see that 4 versions of this app were tested over time, and we monitor how the echo score and how the intermediary scores evolve over time. So this allows us to provide a single grade to assess the quality of the application, but this is not an environmental impact. So we still need to quantify this impact. And to do that, we use a 3 layers approach. So we estimate the environmental impact of the device, the network, and the backend. And we have different layers with different components to do that. So we have different formulas depending on if the device is battery powered or outlet powered. Regarding the network, we account for the core and access network, the LAN of the user, and the customer premise equipment, which is basically the routers that your provider give you and that you use in your home or in your company. And regarding servers, we account for the complexity of the infrastructures. And for each of these steps, we account for both the usage phase in terms of electricity mix and the manufacturing phase. So if we look into the details of the formulas, I will just gloss over that. For each step, we have a formula to define a depreciation of the manufacturing. So basically, we estimate the impact of manufacturing the hardware, and we estimate the lifespan of the hardware. And by doing it, by dividing the manufacturing by the lifespan, this gives us an impact factor for a given unit. Specifically, when we talk about battery-powered devices, the lifespan of the hardware is estimated using the capacity of the battery and the number of cycles that this battery can survive and remain while remaining usable. So, for instance, if you know that your battery will be dead in 100 battery cycles, you can estimate the lifespan of your device in terms of energy. How much energy can I draw for my device before the battery dies? So that's regarding the manufacturing impact. This gives us an impact factor per unit of energy consumed. Regarding the usage impact, it's quite simple. We just multiply the power draw with the electricity mix impact. And we also account for the efficiency of the wall charger, because if you have an 80% efficiency on your charger, this increases the power draw by 25%. So it's still important to account for that. But again, this gives us a usage impact in terms of energy. So both of these impact factors are using the same scale. And then we just need to multiply the measured energy consumption by these combined impact factors to give us an environmental impact regarding the. So in that case, it's regarding the device of the end user. So that's just how to estimate this step of the environmental impact, and we do essentially the same regarding the network and the backend. Something that's important regarding these equations is that we are using impact factors from the literature, and so impact factor regarding the manufacturing of hardware and regarding the electricity mix. So we can use the same formulas for all impact categories. This works for climate change, this works for ionizing radiation, ecotoxicity, and so on. We just need to replace this value in the equation. The equation remains the same. So now we have a set of equations, but in order to compute anything, we need to know the values of each variable. For instance, we want to know the replacement rate at which people replace the battery instead of the whole device. We want to know what is the embodied impact of a smartphone, for instance. We want to know the battery capacity of the device, which change depending on the device. And we want to know the number of cycles. And of course, no one agrees on any of the values. So this creates some level of uncertainty, and we need to tackle it. So to do that, we work on open bibliography, so scientific publications, white papers, reports by ADEM or ARCEP or this kind of institutions. And so this is for a given variable, which is the embodied impact in terms of CO2 for smartphones. For each of the source we find, we of course we fetch the exact value that is reported, but we also assess its quality. So we assess the correlation of the value. For instance, if we want to estimate the impact of manufacturing a smartphone, but the paper talked about a dumped phone, it can be relevant to integrate it, but the correlation will be low. However, if it's specifically the life cycle assessment of a smartphone, the correlation will be high. We also assess how old the source is. Older sources are as regarded as less qualitative, and we check that the authors are reliable. For instance, an academic LCA has a higher quality than some guy's blog. So this allows us to estimate a total data quality indicator, which is a grade out of 12 in that case. And of course, the higher the grade, the better the source is. This is just an example, so don't look into the specific values. So now, instead of just averaging the values, we'll use fuzzy logic to quantify the uncertainty that is introduced by this variability in terms of values and in terms of quality. So with fuzzy logic, I won't go into the details here, but it allows us to create a set of values representing the uncertainty. So it's a trapezoidal fuzzy number. So we have 4 points. Okay, on this plot you have the reported value on the horizontal axis, and the DQI, so the data quality indicator on the vertical axis for each of these source, which are the blue dots. And the trapezoidal fuzzy numbers is on the other axis. So when the membership is 1, that means that we have a high confidence that the value is in this interval. So between, for instance, 45 and 70. And the low this interval at the bottom has a lower quality, so it means that we have a lower confidence that the correct value is in this interval. So this gives us 2 intervals. The smaller one has a higher level of confidence than the larger one. And one of the interests of fuzzy logic is that it's very convenient to store and to compute, because we can, based on this grid, we can create a variable composed of 4 numbers, which are the 4 points here, and this set encompasses the uncertainty of the sources. So this trapezoidal fuzzy number, or TFN, is the embodied impact of smartphones in terms of CO2, accounting for uncertainty. And we will perform the same process for each of the variable of the equations. so all of the variables that I talked about. And the interesting part with fuzzy logic is that it's just a data type. So we use the exact same formulas, but instead of using an integer for these values, we use a trapezoidal fuzzy number. And this allows us to propagate uncertainty across the equations. And the resulting value is also a trapezoidal fuzzy set, a trapezoidal fuzzy number. So this gives us a result which also encompasses the uncertainty of the sources. However, this kind of fuzzy logic is not very useful for communicating, so we need a way to turn that trapezoidal fuzzy set, so the estimated environmental impact, in terms of a single value and an uncertainty level. So there are a lot of ways to do that. Specifically, we use this one, which is a central value and central interval, but the details are not very relevant here. But this allows us to convert a trapezoidal fuzzy number encompassing the impact of the software into a single value, which is here, and some levels of uncertainty, which can be expressed as a percentage. And once we defuzzified the environmental impact, we can bring it back to the user. So for instance, on this figure, you can see the environmental impact of a given application specified for the end user devices, the network, and the backends. And in addition of the exact value that is reported, we also report the estimated uncertainty. Sorry, the estimated uncertainty of the equation. And we also provide the total estimated impact with the corresponding uncertainty level. So I will just recap this process to tackle uncertainty. We start from a bibliographic work. For each source that we find, we perform a critical review to assess its quality, and we fetch the exact value that is reported by the source. Then we use a fuzzification process to build a set of hypotheses, which are trapezoidal fuzzy numbers, encompassing the uncertainty of each of the variables of the equations. Then we apply the algorithm that estimates the environmental impact, which return a trapezoidal fuzzy number. And using a defuzzification process, we turn this trapezoidal fuzzy number into a single value and some level of uncertainty. A point that I mentioned here, which is quite important, is that the uncertainty that we report only quantifies the uncertainty in the bibliographic work. So it's just a quantification of how much people disagree regarding the impact of the device involved in the process. We don't account, for instance, for the uncertainty of the hypothesis itself. We don't have any quantification of how good our equations are. Okay, and just this impact that we estimate is an environmental impact for one single execution of the functional unit. So we need a scaling factor to account for the impact of a global app that is used by a lot of people every day during a given time period. For instance, if the application is used by 10,000 people during 1 year, we can convert this unitary impact to a global impact for the application. Okay, just a point. I talked about two different grading, two different methods here, which are grading with the echo score on one side and the quantification of environmental impact on the other side. And these two systems are very different and they don't quantify the same things. The grading of the application only quantifies the software itself. So it's an empirical evaluation of the source code that runs on the end user devices. So it estimates the impact of the application in total isolation from its context. Whereas the quantification of environmental impact accounts for the context, including the types of networks that the user rely on. Is it 5G or 4G or fiber or so on? And it also comes on the location. If your users are in France or in Poland, it's not the same impact that is estimated here, but the eco score will be the same. So if you improve your grade, you can expect the quantification of environmental impact to also improve. However, it doesn't go the other way around. If you decide to bring your server back from Germany to France, this will reduce the impact of the application in terms of environmental impact, but it will not affect the grade of the application. So these two methodologies are designed for different people. For instance, the grading is more designed for developers, while the quantification of environmental impact is more for the organization itself to know how to manage its projects. So they report different values and they have different targets, and that's why we need them to coexist. Okay, we'll arrive to the end of this presentation. So just a quick recap. We started from a service that we want to assess and that we divided into a set of user journeys implemented in GDSL. And we want them to run on physical devices which are located in our office. And to do that, we have some level of automation which allows our users to trigger some tests arbitrarily from their office into our test bench. And this kind of tests provide different types of results, which are an eco score, which is a grade regarding the application. We also provide dashboards to analyze the metrics of the application over time. And we provide an estimated environmental impact, accounting for uncertainty in the sources. If you are interested in more details regarding this white paper and this methodology, the publication itself is available on our website, so you have the exact formulas, you have more details regarding fuzzy logic. We also specify all the grades that are used to compute the eco score and how they are estimated. So if you're interested into that, you can download the document on our website. And of course, I remain available if you have a question here or on LinkedIn or by email, or I'm not hard to reach. So it's the end of this presentation. I already some questions from Benoit regarding the impact of WAN and data centers. So we'll go back to that soon. Here, okay. So for the network, we have different sources regarding each network technology. So we have sources regarding 2G, 3G, 4G, and 5G, regarding fiber and copper. And for each of these sources, there are some sources that only talk about the core network or the access network, but we manage that by summing them. The impacts are estimated based on the network volume. So we are multiplying a number of kilobytes by an impact factor per sorry, I'm reading other questions at the same time. So we are multiplying the volume of data by an impact factor per network type. And the mix of network type is based on public data, so generally we are based on RCEP. There is a report by RCEP stating how much users are using copper or fiber, and we use data from the developers to know how much are using mobile network versus fixed networks. I don't know if I answer your question, Benoit, regarding the one. And regarding the servers, our model is weaker regarding the servers because we only have, it's a black box, so we don't have much data regarding the infrastructure of the user. We use some scaling factor regarding the complexity of the infrastructures, and which allows us to estimate an impact over the lifetime of the hardware and the number of requests that is sent to the backend. However, our model is not as so as what can be done, for instance, in the project of Boavizta. And we know that we are stronger on the device part, and we are okay on the network part, but the backend part still needs some improvements. Okay. Yuan, I saw that you asked about the equation. Sorry, Adeline?
Oh, so you have questions from Damien, so go ahead.
Yeah, so I saw a question from UN regarding the backends. I just talked about it, but if you need more details, I can expand on that. Regarding a question from Damien, could you explain more about eco score? How do you calculate that score? Yes. No, it's sure. So the global eco score is based on the scores of the steps, and each step is graded regarding 5 indicators. And the decision to provide 1 or 2 or 5 to a given step is based on empirical data that we have. We know how much, for instance, we know for all the steps that are in our database, we can compute how much of them are the 20 best percent, how much of them are between 20 and 40%. So it's purely empirical. The decision, the grading, for instance, this grade 2 out of 5 means that these steps perform better than 60% of the data set of all the steps that we monitored over time.
Edouard?
Yes.
Yes, it's Yun. Regarding my question, because when I read the paper, they want some equation on the backend, on the servers. I don't think I saw them in the slide. I just wanted more details.
No, I didn't go into the details regarding the network and backend. So I just mentioned it very quickly to Benoit regarding the impact of data centers. But essentially, we take our methodology is to estimate the total amount of requests that a server can handle in its lifespan, which gives us an impact per request, which is treated by the data center, by the servers to be exact. So we don't account for all the surrounding. Sorry, I don't know if
Yeah, because in the paper there is a P factor. I think it was. I thought it was the energy measured on the backend or the server part, but I guess it's not now.
We don't do any measure on the backend. I just need to be totally honest, I don't have all the equation in my mind right now. Must be on my computer though. I will look into it.
So chapter 4 to 5. if you don't know this part, it's okay. Just
Okay, so which is the equation number, please?
17, 18, 19.
So there's a lot of equation. Yes, the average power usage is not based on measure. It's based on sources regarding the average power draw from servers. So we don't do measure. It's based on bibliographic work regarding the power usage of the devices.
The average power usage is from the devices, not from the server. Okay.
No, sorry. The power usage of the server itself, but it's not measured. It's based on bibliographic work.
Okay, thank you. Got a better understanding. Thank you.
Benoit, I saw that you talked about an A by X function regarding, I guess, the I don't know if you are talking about the one of the server. Yes, yes, it's an A by X, but we account for the different type of network. So yeah, it's No, it's not a fixed impact. It depends on the amount of data that is transmitted and on the information that the developers provide us regarding the actual usage of their application. Because developers sometimes know if people are using a given app at home, so behind the copper or fiber, or if they are using it on 5G or mobile networks. And Damien, I see your question is the part that explain in tools how it was calculated.
Yeah, my question was linked to EcoScore. In Greenspector, do you share how you calculate this EcoScore to help to do action for design? I see the slide, but directly in Greenspector, do you help them?
Yes. We work as a black box, so we don't have the internal, we don't have specific explanation regarding the cause of energy issue, for instance. So we can't say the issue comes from this part of the code and you need to change that. However, what developers generally know what happens in their code during these steps. So they can sometimes, just by seeing this, be able to locate the cause of the issue. But we don't provide specific information regarding how to improve it. And if we provide information, it's quite generic information, like you need to remove this kind of useless feature, you need to remove animations, and so on. If you need specific details about how to improve, you may need to rely on external tools such as EcoCode, for instance, to locate specifically the root cause of the energy issue.
Thanks.
I don't know if there are other questions, or maybe I missed some in the chat.
No, I think you answered everyone. If you guys have questions, feel free to write them in the chat or speak directly. All right. Well, I guess we're done then. Thank you very much, Edouard.
Yes, it was a pleasure to talk here. And I know a lot of people in the chat, so I won't say nice to see you again because I didn't see you, but to see so much people here.
Well, thank you, everyone, then.
Bye.
And have a nice day, everyone, and we'll see you in 2 weeks.